All right, let's dive into one of the biggest, and I mean weirdest, questions in all of science. It's this fuzzy, blurry line where physics meets philosophy, where the person looking at something might be just as important as the thing they're looking at.
I mean, it sounds kind of crazy, doesn't it? But believe it or not, for the past 100 years, this exact question has been this ghost in the machine at the very heart of our best theory of the universe, quantum mechanics.
So, to really get why this is such a big deal, we've got to start with the main puzzle of the quantum world. We're talking about a contradiction so profound that it led a Nobel Prize winner to suggest something that sounds like it's straight out of science fiction.
Okay, so the heart of this whole thing is a concept called superposition. And what it means is that a tiny little particle, until you actually look at it, it isn't in just one state. It's kind of everywhere it could be, all at the same time. The best way to think about it is like a spinning coin. While that coin is flipping through the air, is it heads or tails? Nope, it's both. It's this blurry potential of being heads and tails all at once.
And here's where things get really weird. It's like quantum mechanics plays by two totally different rulebooks. Rulebook 1, when nobody's looking, the system just hums along, all its possibilities evolving nice and smooth, totally predictable. But Rulebook 2 kicks in the second you try to measure it. The instant you look, bam, that whole cloud of possibilities just vanishes, and it randomly collapses into one single reality. The spinning coin hits the table.
Now, one of the absolute legends of 20th century physics, a guy named Eugene Wigner, he looked at this two-rule system, and it just didn't sit right with him. He called it a strange dualism. I mean, think about it. How can reality itself have one set of laws for when we're not watching, and a totally different set for when we are? It just doesn't make sense.
But Wigner wasn't the kind of guy to just complain about a problem. No, he came up with a solution. And it's an idea so wild, so mind-bending, that it basically says our own minds, our consciousness, are an active part of creating the universe we see.
But hold on, before we get into what he proposed, you need to understand who we're dealing with here. This wasn't some random person with a crazy theory. Eugene Wigner was a giant. He worked with Einstein, was a huge player in the Manhattan Project, and he won a Nobel Prize. The point is, his ideas, no matter how out there they sound, came from one of the most brilliant minds of his time.
So what was his big idea? He said that the collapse, that moment the coin lands, it doesn't happen when some machine clicks or a needle moves. No, he argued, and this is a direct quote, the measurement is not completed until its result enters our consciousness. Let that sink in for a second. What he's saying is that consciousness isn't just watching the show, it's the end of the show. It's the final piece of the puzzle that forces the universe to pick one path, to stop being a blur of maybes and become a solid, this is what happened. Basically, the coin is still spinning until a conscious mind actually looks at it. To show just how weird and wonderful this idea really was, Wigner came up with this amazing thought experiment. It's kind of like an upgrade to the famous Schrödinger's cat puzzle, and we call it Wigner's friend.
Okay, so picture this. Wigner has a friend, a fellow scientist, and she's inside a perfectly sealed lab. No information gets in or out. Inside, she does an experiment. She measures a quantum particle. From her point of view, inside the box, the superposition collapses. She gets a clear answer. Let's just call it spin up. For her, the experiment is done. Reality is fixed. The coin has landed.
But, and here's the kicker, what about Wigner's perspective standing outside the locked door? He hasn't seen the result yet. So according to the rules of quantum mechanics, the entire lab, the particle, the equipment, and even his conscious friend is now one giant superposition. To him, his friend is in this unbelievable state of both having seen spin up and having seen spin down at the very same time. It's only when Wigner opens the door and asks, hey, what'd you get, that the whole thing finally collapses for him.
And this just throws us into a massive paradox, right? When did reality actually become real? Was it when the friend saw the result, or was it only when Wigner saw the friend? You've got two different realities happening at once, and this contradiction is exactly why Wigner said, see, consciousness has to be special. It must operate outside the normal quantum rules.
Okay, but if we follow this logic, that consciousness is what makes reality real, we end up going down a pretty deep and dark philosophical rabbit hole. I mean, if my mind collapses the universe for me, what about yours?
This leads us straight to a philosophical idea called solipsism. And it's the theory that you can only be sure that your own mind exists. Everything and everyone else, the whole world, might just be a figment of your imagination.
It's a pretty lonely way to look at the universe, to say the least.
And to his credit, Wigner was intellectually honest enough to follow this idea all the way to its really uncomfortable conclusion. He basically wrote that, to be really precise about it, it's not just any consciousness that does the collapsing, it's my consciousness, since I am the only observer. In this view, you, me, everyone else, we're all just parts of the quantum system that his mind is observing. Yikes.
So yeah, for that reason, and a few others, this whole consciousness hypothesis, it hasn't really stood the test of time. The philosophical problem is just too big. And think about it practically. We have automated experiments all the time. A space telescope records some data. Does that little piece of reality stay in limbo for years until some grad student finally opens the file? Most scientists would say, probably not. In fact, even Wigner himself started to have second thoughts later in life. He saw the problems his idea created and said he had a desire for a less solipsistic theory. And you have to respect that, right? He was brilliant enough to ask the question, but also humble enough to admit his own answer might not be the right one.
So, if Wigner's wild idea isn't the answer, what is? Where does all this leave us? Well, it leaves us pretty much right back where we started, staring into the face of one of the biggest mysteries in all of science. That measurement problem, the whole two rule books thing, the strange split between a thing being watched and a thing that isn't, it is still 100% unsolved. To this day, physicists are arguing about it, throwing out ideas from parallel universes to totally new laws of physics.
And that, right there, is Wigner's real legacy. It wasn't about him getting the final answer right. It was about him having the guts to ask the most difficult question imaginable, and in doing so, forcing science to look itself in the mirror and deal with the strange, unavoidable fact that the observer seems to matter.
He left us with a question that's still bouncing around the halls of physics departments everywhere. A question we still have no good answer for. Where exactly do you end